Hello guys, thank you so much. Thank you so much for bearing with me, through this derivative operators video. And I think, I'm gonna make this video and stop this for a while and then maybe I'll come back with something new, something exciting. But today, I'm gonna cover the last characteristic, okay? I will cover the last characteristic that I think is kind of vital. I think um the characteristic is that, okay, let me write a temporary final characteristic of our great series, like a movie, right? I don't know, how would you rate this series on the IMDb? Leave in the comment section below. Now yeah, so what is the characteristic? The characteristic is, if you have this y1 equals 0, this you will have, definitely you will have this. C1 y1 plus C2 y2 equals 0. Now the opposite side, this side, I'll leave this for you. Like, this is the left, this is the right. From left to, in this video, I'm gonna go over, like, if you got given at left, you can obtain right. But the question for y'all, I'll leave this y'all as an exercise, that if you given right, can you obtain left? Okay, so now let's gonna do that. I'm gonna go ahead and do that. So I'm gonna rewrite right. What is right? Right is d minus a, d minus b times c1 y1 plus c2 y2, right? The goal is to show that r equals 0 given L. Okay, so now I want to expand it because it's linear. I'm using like additive and multiplicative properties of linear operators. So this is additive, and I'll show you. It's really cool. C2 y2. Okay, now I'm gonna rewrite this. I'm gonna put C1 here. I'm gonna put C1 out. Put C2 out. C1 d minus a, d minus b, y1 plus C2 d minus a, d minus b, y2. Right? Okay. Now I'm gonna rewrite it so that the left side here. So I'm gonna rewrite the first component of r like this. Okay, I'm gonna just swap it. y1. Okay, and then I'm gonna put this thing right here later. You guys understand why I put it like there's C2 a d plus b y2, right? Oh god, I forgot this bracket. So many bracket for a broken heart, isn't it? Okay, so from left we know that d minus a y1 is 0, so this is become 0. Similarly, from left we know that d minus b of y2 equals 0, so r equal c1 minus b 0 plus c2 d minus a 0. Let's try it in for me. Oh, what is it? Okay, cool. What is d minus b of 0 mean? Mean that d or dx of 0 minus b times 0 plus c2. Okay, again, I'm gonna assume every function in our series is a function of x. Okay. You guys can, yeah, if you want, you can, yeah, for the sake of this argument, dx 0 minus a times 0. So r will be equal to c1 times 0 minus 0 plus c2 times 0 minus 0 equal 0. Okay, so we successfully proved that, from left you can obtain right. Okay, using, this is additive. Let me write where I use additive. This one right here, I'm use additive. And this one I use here multiplicative. Yeah, exactly. And the question is, can you do it the opposite way? Well, I'm gonna leave it up to y'all. It's very interesting. This problem cannot be taken seriously. It have to be taken like seriously. Sorry, I keep confusing myself all the time. Like, but I'm so sorry. Like, my recommendation, maybe you can get this, go 0, and then you'd be like, yeah. But that's a very good point. Okay, so with that being said, I'm gonna assume the red one is true for now. So I'm gonna assume it's 2 side for now. So you have right, you got left, you got right. You have left, you got right. You have right, you got left. Okay, but the right to left, I'm gonna leave for y'all. I'm not really clear about it, so I'm not gonna do it. But I believe that you can figure it out, and let me know in the comment section below. Okay, so let's say you want to solve this differential equation. Let me think. What should I give you? Okay, let's say you want to solve this differential equation. What are you gonna do? First, you write it like this. Alright, equals 0, and then you factor out 3 plus 10 dy equals 0. Oh god, y equals 0. Okay, what's this? This d minus 2, d minus 5, right? Y equals 0. Okay, now you're gonna solve for this. You gotta solve for this separately. Okay, what do you get here? You get y1 equal to e to the power 2x. Oh no. So what you got? You got here you got e to the power 2x d e to negative 2xy equals 0. So you got d over dx e to negative 2xy equals 0. So you got what? Y equals c1 e to the power 2x. Right? You agree? Similarly, e to the power 5x. No, 1. y1. Sorry, it's y1. D to the power e to the power negative 5x y equals 0. So d over dx negative 5x y equals 0. So y2 equals c2 e to the power 5x. Then you can be like, y is c1 y1 plus c2 y2 equal oh, okay. Okay, no problem. c1 square y1 plus c2 square y2. c1 square is just a number. I can replace c1, and c2 square is a number, so I can just renote this as c2. Okay, so y is c1 y1 Oh, actually, I'm sorry. God. C1 y1 is, so this is c1 squared e to the power 2x from, let me see, this 1, this 2, from 1 plus c2 squared e to the power 5x from 2. C1 squared is a number. You replace C1 for second simplification. C2 squared is also a number. Why don't you write C2? So it's more simpler. And ladies and gentlemen, this is our general solution. Now, my theory for this is that it's a sort of linear combination or something, but I'm gonna leave it for y'all in the future. Okay, I'm sorry this video is kind of rushed. But I hope you learn something, or even if I'm wrong, like you can see my mistake and improve on your field mathematics, and maybe one day make a better proof than I do, and I believe you can do it. Okay, you have a good day, good time, wherever time you in, and thank you for your attention.